So, similar to what we have talked about earlier with respect to restrictions when we come to when it comes to dimensions and shapes. Once we introduce any restriction to our problem, then we're not gonna have a cube anymore, right? When we're talking about optimizing the surface area and the volume. So the shape will not be a cube anymore, okay? So the minute that they introduce one type of restriction, so the restriction could be that one of the sides is missing, or the restriction could be that one of the faces are missing, or the restriction could be that one of that it's going to be decimal, not whole number. So all of this will play into effect of what kind of shape I have. So let's read the next question. Let's see what kind of restriction do I have here. So Jacob is designing a glass candle holder. It will be a square-based rectangular prism with outer surface area of 225 centimeters squared and no top. Do you see any restrictions here?
Yeah, no top.
No top. So right away, I lost one face, right? If you look right here, if this is my candle holder, I don't have this top. So it's not a cube anymore. Now, but there's another restriction to my problem here, and that is it has to be a square-based rectangular prism. So when I'm solving for my dimensions, I'm going to have to take into consideration that my base is a square. Okay? So let's try to build that. I can't draw 3D shapes, so this is the best I can. I'll apologize. Okay? So I know that the base is squared. So that means if this is L, what would this be?
L.
L. And then this is going to be?
L.
No, H. It's not L anymore because it can't be a cube because I introduced a restriction. Now why is both the bases, the sides of the bases are L and L? Because it's a square-based rectangular prism. So it's forcing it to be two equal sides.
So wouldn't all sides be equal too, like that side and
That side,
Yeah.
that side, yes.
Okay.
Okay? So, if I'm going to look at the volume of this particular shape, what would it be? What would the formula be?
Length times width times height?
But do I have W?
No, like L squared.
L squared
H.
times H. That's right. No, you said 2L. 2L is not the same as L squared. Right? 2 times L, that means you have L plus L. L squared, that means you have L times L. There's a big difference there. Okay? So, in this case, the volume is going to be L squared times the height. Yes? Good. So what did I say about perimeter? Sorry, not perimeter, surface area. You're all looking at me. What did I say about surface area? How do I find a surface area in general?
I see that.
Sorry? That's for another kind of shape. So if you're thinking about this, I want to find the surface area of this, I have to find the area of this side, the area of this side, the area of that side, and add them together. This is what a surface area is. Finding the area of all sides, of all faces, and adding them together. Okay? Now, let's think about this particular shape. How many faces do I have? 5. 5, because I'm missing the top. So let's start with the base. What's the area of my base? So let's start with this, with the base of this. What's the area of that? L squared, right? Because it's L times L. Okay? So the area of the base is L squared. Good. Now, how many other faces do I have? So I've already figured out this one. How many other faces do I have to figure out? 4 others. What would be the area of the front face that you see right now? Length times height. That's right. Length times the height. How about for this one?
Same.
How about for the back? How about for the side?
Same.
So how instead of saying length times,
4 times
it will be. So the area of the sides are 4 times length times height. So my surface area in total is going to be, surface area is going to be L squared plus 4LH. So first thing I did is I figured out my volume formula and my surface area formula, because in this case they're not going to be the easy peasy ones with like L cube or S cube or whatever, and then okay? Because they're, yes.
Why is the age in replacement of the width with regards to that particular thing?
The width is going to be down here. The height is always this. The width and the length are equal to each other.
Yeah.
So instead of width, I'm using L and L.
No, the age, the height. In respective to that figure, why is it not width? Because the area of what that would be length times width. But
Times
here-
height.
Right. So why is it height and not width? Considering that it is a rectangular prism.
But it's a square-based rectangular prism. If you're talking about a regular rectangular prism, this is going to be your length. This is going to be your width. This is going to be your height. I didn't replace the height with the width. The width was right here. But my width is the same as the length. So why would I call them two different things? Right? I don't need extra letters. The less letters I have, the better it is. Are we okay with that? Are we okay with that?
Why does the height have to be different though?
Because it doesn't say 8. Because you have a restriction. So right now, because of the restriction, it's not a cube anymore. Remember how we did in the 2D, when we added a restriction, it's not a square anymore? Same here. When there is a restriction, it won't be a cube anymore. Okay? And then your formulas are going to be different. You're going to have to come up with the formulas. You see how we came up with these two formulas right here? You're going to have to come up with these formulas by looking at the shape and studying the shape and finding out what the surface area is and what the volume is. Can I continue or not? It's not going to be an easy question, I'm telling you from now. Okay, now, I'm going to reread the question. Jacob is designing a glass candle holder. It will be a square-based rectangular prism with outer surface area of 225 centimeters squared and no top. Determine the maximum volume of the candle holder. What is given to me? The surface area. So which formula do I want to start with? The surface area, which is this. Right? So the surface area is 225, so I'm replacing the surface area with 225, and it's equal to L squared plus 4LH. So all what I did right now is instead of the letters SA, I replaced it by its value, which is 225. Now, how how many variables do you have? 2 variables, right? With the 2 variables, you can assign for one of them some numbers, and you can solve for the other. Okay? So in this case, I've already assigned value for the length, right? I've given you that the length could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you're gonna have to solve for the height, given that the length is these values. Okay? So I know L, I'm looking for H. Now, why did I pick values for L and I'm looking for H? Why not the other way around?
Because the L is for the square, so it's like the length of each side of the square, so because you already have the square itself is perfect square, so it's the same number each side, just the height that you don't have.
Okay. That would be like one of the reasons why. Anything else that you can think of? There is a reason that has to do with the formula.
Two L's in the formula.
That's right. There's 2 L's in the formula. To isolate for L, which L am I going to isolate for? How am I going to do that? It's not doable, right? There's only one H. I can isolate for that one H. Okay? So it's easier to isolate for H than to isolate for L. Can you isolate for H for me?
Yeah.
What do we do?
1 squared plus 4 times 1.
No. I'm isolating for H.
Oh,
So,
oh.
Eric?
So you input the value you're given, so for instance, it's the base.
What if I don't want to input the values? What if I just want to, using this formula right here, I want to isolate for H?
Side by side by,
You divide by 4.
What about this L squared? Don't I have to move it first?
Divide by,
Okay,
so 25 L squared.
minus. So I have to move that one first. Right? And then I have to divide by 4L. So, I know what my L is, I can plug it in, and I can solve for H.
no, like your face. I'm sure
Okay.
it happens.
How do you isolate for X?
How do you isolate for X? 10 minus 5.
Okay, so first you're gonna have to move this, right?
Yeah.
Good.
And
Then,
then, X is equal to 10 minus 5 divided by 2.
good. Right?
Right.
Because we're doing opposite operation. Good. Exactly the same thing. Instead of 5, I have L squared. Instead of 2, I have 4L. I want to isolate for H. So I want to leave this here, and I want to move everything else. So the first thing you want to get rid of is the addition. Because we're moving backward of that mass. Right? So that's why we subtract L squared first. Then we divide by 4L.
Would it be safe to say that we start with the one that's closest to the equal sign?
No, it doesn't have to be, because I could write as 4LH plus L squared, right? Okay. All right, let's get this started. I can see the blank. Okay, so I know the L values. All what I have to do is plug in the L value, right? This value in for L and solve for H. So every time I have to plug in the L value in, solve for H. Okay? So if L is 1, what do I get?
24
225
minus
minus 1 divided by
4.
4. So 225 minus 1 divided by 4. Why? Because 1 squared is 1.
Yeah.
So 225 minus 1, and then
Divided
L is
by
1, so divided by 4. So that's what's 224 divided by 4. What's 224 divided by 4?
It's 56.
Good. So, the height is 56 while the base length is 1. The height, we'll just solve for it, is 56. And the length of the base is 1. 1 by 1.
Right.
Okay. Now, how can I find the volume?
Plug in.
So plug in 1 for L, and what do I plug in for H? 56.
Yeah.
So it's gonna be 1 squared
Square
times 56. So it's gonna be 56. Okay, use a pencil, please, and fill out the rest. So you're gonna have 2 for L, you're gonna plug it in to find H. Then you're gonna find the volume for me.